Hey geometry class, this is our lesson on section 6.5, and what we're going to be doing is learning a few more of these proportionality theorems. Nothing to do with side angle side and other sorts of things like that, but you will see in this lesson we have 4 proportionality theorems and they go along with each other quite well. So let's take a look at a couple of them. So here's a couple of our theorems. They're converses of each other. So let's look at this first one. If a line parallel to one side of a triangle intersects the other two sides, then it divides the two sides proportionally, is what that blank is supposed to say. So let's write that in. Okay, so let's look over here at this figure in this statement right here. So what this is saying is if we know these two sides of our triangles are parallel, then we can say this statement right here, that RT over, so RT here, over TQ is equal to RU over US. And that's what that means right there. So if we know that this statement is true, then we can make this conclusion right here. Now, the other way, if we know that these two segments are proportional to each other, so if this, then the two opposite sides are parallel to each other. So these two sides right here are going to be parallel. And how this thing is going to be stated is if a line divides two sides of a triangle proportionally, then it is parallel to the third side is how that's supposed to be stated. Oops. So what goes in this box or these blanks right here are that QS is parallel to TQ or TU. Now let's put these in use. So putting these to use, your exercise will look much like this. You'll be asked to find a portion or a segment on your figure. So this is asking us to find what US is equal to. Knowing that these two sides right here are parallel, we can use that triangle proportionality theorem. And this could be our statement right here, that RU, this right here, RU over US is equal to RV over VT. Now let's plug everything in with our numbers that we have. So RU is 14, US, that's what we're trying to figure out, RV, that is 10, and then VT, that is 4. All right, now do your cross multiplication and we'll get 56 equals 10 US. Divide both sides by 10 and we get 5.6 is equal to US. And there we go. We figured out what US is equal to. Now, example 2 is using the converse of the triangle proportionality theorem. And so this will look like this right here. It'll say verify that the two segments are parallel to each other. So how you verify is you set up the correct proportionalities. So to verify that these two segments are parallel, this proportionality statement must be true, that AD over DB is equal to AE over EC. So this segment over this one is equal to this segment over this one, is what I just stated. Okay, now verify that by plugging in numbers and seeing if it is true. So 10 over 15 is what I get for that one, and then 8 over 12. Now, if we reduce both of these fractions, we will get 2/3 is equal to 2/3. So this is true, that this statement of proportionality is true, and therefore that verifies this statement right here, that these two segments, DE and BC, are parallel to each other. Okay, on the next two theorems, this 6.6 is very much like the previous one, but it says here, it says if three parallel lines intersect two transversals, and then they divide the transversals proportionally, is what this is supposed to say. Okay, and how we're going to make this statement right here, it says, so this segment right here, UV over UW over WY, that is going to be equal to this segment over this one. So VX over XZ. And we'll use that in an exercise here in just a bit. Now on 6.7 theorem here, it says if a ray, hold on, whoops. If a ray bisects an angle of a triangle, then it divides the opposite sides into segments whose lengths are proportional to the lengths of the other two sides. So again, proportional. So over here, what this is going to see, and what you're going to see is if you have an angle bisector going through your triangle here, that angle bisector is going to do this to your triangle. So this segment here, AD over DB, is equal to this side of your triangle, so AC, over this side of your triangle, BC. Okay, so let's put those to use. Okay, so this is going to be using that 6.6 theorem about parallel lines intersecting two transversals, because we have three parallel lines here, and we're asked to find the missing length. What is this right here? Well, I'm going to call this X, okay? And to divide it up like the theorem states, this segment length right here is going to end up being 3, because 5 is this whole segment right here. This is part of it, and then that is the rest of it. So 3 plus 2, that is 5. All right, now let's set up our proportions. Whoops. Okay, so let's say x over 4 is equal to 3 over 2. Now solve for x. So you can do cross multiplication, or you can just multiply both sides by 4. And when you multiply both sides by 4, which is what I'm going to do, this cancels, and you're left with x equals 6. And there you go. We found the missing length. All right, so in this example, this is the last example I'm going to work for you. The last 3 you're going to have to do on your own, and we'll go over those in class. But example 4, this is the theorem that we're using, the triangle angle bisector theorem. That's just another name for theorem 6.7 that we looked at. And we're asked to find the missing length that right here, the one with the question mark. So this is how I would actually go about it. I would say, let's find, because we know these two angles right here are congruent, meaning it's bisecting the angle. This whole angle right here is being bisected by this segment going through it. We can split up our proportionalities like this. We can say x over 7, this is how just follow the theorem, is equal to, now this side, since you stated x, state the side length that it's adjacent to, so 20, over this side, 28. And solve that for x. I do it by multiplying both sides by 7, and x is equal to 5. All right, now don't just stop there because that is what this side length is equal to. Our x is right here, but we're asked to find the entire side length. So what we do is just add 7 and our x value, which is 5, together, and we get, let's see, 12. So right here, this question mark is 12. Okay, let's look at the last slide here. So on these, it's just like the previous problems that we have looked at, applying those theorems that we have looked at in this section. So figure these problems out. Like I said, we will go over them in the class the next time I see you. So I'll see y'all then. Goodbye, everybody.